Scott Stroz. And that is the only French you're going to hear out of me for the rest of the talk. It took me weeks to learn that. My name is Scott Stroz. I'm a developer advocate for MySQL, and we're going to talk today about using MySQL, Node, and Testcontainers to write tests for your code effectively. A little bit about me first, the obligatory I love me slide. I'm a full stack developer. I have been a full stack developer for longer than the term full stack developer has actually been in existence. Basically, we used to just call ourselves developers. In the entire time I've been a developer, the only constant has been MySQL. The backend language has changed, front-end languages have changed, but MySQL is something I've been using nonstop for the last 23 plus years. I'm a diehard New York Giants fan. For those who don't know, that's an American football team who, unfortunately, for the last decade or so, has not been very good. I've become smitten with writing tests for code. I used to hate it, and the reason why I used to hate it is because it's difficult, and it's hard to learn, and it's hard to get good at, but once you get good at it, you realize how important it is. And I have the best office mate in the world. This is my Labradoodle Murphy. He pretty much spends all day, every day in my office with me. If you don't have a pet, you should get one because they're really good about talking problems through, especially if you work from home, you don't have coworkers. I just sit there and talk to Murphy about a problem. He looks at me with those eyes, and then I get the solution. He knows more about databases than any dog in the world. So why should we bother testing our code? There's a couple of reasons. One, it helps being able to find bugs faster. This means that if you have proper testing coverage for your code, you are more likely to find a bug before it goes to production. Notice I said more likely. That doesn't mean stuff's going to pass through because really, it's only going to be as good as your tests are. Hopefully you'll take something out of this to be able to learn how to do testing a little better. It helps in debugging. If you have an issue that pops up that there's not a test written for or there's not a good test, you can write a test that will reproduce the issue, and then when you fix the issue, that test should then tell you the test or the issue is now fixed. And you can use that in an iterative process. It can assist in reducing code complexity. If you're writing unit tests and your unit tests are really complex, guess what? That means the code you're trying to test is too complex and you probably need to break it out into diffs. So if you have one monolith method that does a lot of stuff, you might want to break that into smaller methods because it'll make it easier to test and it'll make it easier to find problems down the road. Obviously, you can improve code quality because if you're testing your code to make sure there's no issues, then your code is less likely to have issues, assuming you write good tests. And I've actually seen some places where they use the test as an adjunct to documentation. Two main kinds of tests that we talk about in software. There's unit tests and there's integration tests. And a lot of people have a hard time understanding what the difference between the two is. I know I used to. I didn't understand really what the difference was, and I tried to come up with an analogy to make it easy to understand, and I think I did a pretty good job with this one. Unit tests are focused on a single function or a single method, and that method is tested in isolation. Meaning when you run a unit test against a method, you're only testing that method. If we owned a jigsaw puzzle company, and we had a quality assurance to test our jigsaw puzzles, a unit test would be akin to testing each individual piece. So if you imagine you have some specs for a particular jigsaw puzzle piece, you can say, yep, that piece is good. That would be a unit test. Integration tests test your entire system end to end. So this is where you're actually testing how your code interacts with itself. And it verifies that the different parts of the application are working as expected. That you have, the process that handles users is working correctly with the process that emails users, that handles the process of, registering users. You making sure that all works together. Using our jigsaw puzzle analogy, integration tests would be testing the entire puzzle once it's complete. So unit tests, we're looking at each individual piece. Integration tests, we're looking at the entire puzzle. Now, sometimes people say, well, if all the pieces are right, then how could the puzzle be wrong? Well, I say, well, you're not a developer. Because a lot of times, all of your unit tests could work fine, but your integration tests are going to fail, or some of them are going to fail. Testing code that interacts with a database is difficult to do. And the main reason why is because it really is a combination of unit tests and integration tests. The reason why is because our code that writes to the database, you really can't, by the definition of it, you really can't unit test that, because in order to write to the database, you have to hit something outside your code. So it's kind of a unit test because we're just testing the save user function, but it's an integration test because we have to make sure that data went to the database that's outside of our code. And when you're doing database testing, or when you're testing code that hits a database, it should be done on an island. There should be a completely separate instance that is just for testing, and that database should be as pristine as possible before you start your tests. That could be a problem in a lot of places because the database might be too big for people to run on their laptops. The database might not be allowed to be run on your laptops. The last project I worked on before I joined Oracle, we had a team of about 10 developers. We had one testing database, and it was remote. So if you had two developers that were working on the same module at the same time and they ran the test at the same time, both of them usually had huge failures because what one did was different than what the other person was expecting, and there was lots of collisions. That shouldn't happen. Test containers. How many people have heard of test containers before? Oh, one. Good. Oh, a couple. Well, you heard it from me. So test containers is actually a really novel idea. It's a Docker-based solution. You don't have to use Docker. I actually have Rancher on my laptop to run them. Where in your test code, you can spin up an instance of MySQL, apply any database changes you need, and then run your tests against that. And then when your tests are done, you kill the container. It's actually pretty cool. You can also set up your container so that if you have a mature database where you're like, I don't want to run all these scripts every time I run test runs. So I've known people that what they do is when they hit a production build, they take a snapshot of the database in that state and they apply that to the Docker image so that the next round of testing starts, you're starting with a more mature database and you only need to apply any changes that have happened since that last production. So how testing should work. Obviously, if you have tests, you have to write your tests first, but you start your tests, you spin up your testing container running MySQL. You apply any database scripts or migrations that are needed for what you're working on. This could be you're adding a column, you're adding data, you're adding a whole new table. You run your tests, you shut down your container, and then you bask in the glory of your flawless code. One small problem. That almost never happens, that last step. What usually happens in the last step is you curse, and then you have to make code changes, and then you start the process all over again. Very rarely, like if I'm writing some code and I write some tests, or I have some tests and I write code, and the code passes the first time through, my brain's like, you did something wrong. Because the way I write code, I should have some failures initially that I then have to correct as the code gets better. For the demo that I'm showing, I'm using the Node test runner. It is a built-in test runner in Node that's been there since version 18, but it really matured around version 21. It eliminates the need for third-party testing frameworks or third-party dependencies, and it supports a syntax and a structure that's similar to Mocha, Jasmine, and Jest, if anybody have used those before. For the demos, the project structure is very simple. There's 4 files. There's user repository, which is the code that we would use in our application to interact with the database. That's specifically dealing with users. We have a file called ddl.js up in the setup folder. This is actually going to get run when the tests start up, and what it's going to do is inside of our empty MySQL test container, it's going to create a table. That's all that file does in this demo. And that is probably where, if you had to apply database migrations, you would do it there. Anybody here use Liquibase or heard of Liquibase before? Okay, you can actually integrate Liquibase into your test so that when you spin up your test, you can apply the migrations to the database that spins up in your test container. And then we have user repository.test.js. That's the test file, in case you didn't know. And then datautils.js. That's kind of a process that I use. So when we run our tests, we're going to use user repository to perform the action that we want, and we're going to use datautils to test that action worked the way we thought it did. So this is our test file. You good with that? Can you guys see that?
Yeah.
Wait, hold on. There we go. So at the top of our test file, the first 4 imports are libraries that we use. So we have the node test runner, node assert. By setting node assert as strict, that is like doing not just a value comparison, but a data type comparison. If you didn't use assert strict, then the number 3 and the string 3 would be equal. By using assert as strict, it wouldn't be. Then we have Faker. Faker is an awesome library for testing because it creates really good fake information that you can use. So you can create a user or a username using Faker without having to come up with some other process. I used to write my own stuff, and this is so awesome. You can do random numbers, random strings, usernames. It's really a good process or a good library. The last 3 are the ddl.js. That's the script that creates a table, user repository, and datautils.js. You'll see we start this with a describe. In the node testing framework, when you use the describe function here, you're basically creating a suite of tests. So what you do is you take your tests that are kind of related to each other, and you put them into a suite by using describe. And you see here we have the description is Scott's amazing test demo. We create some variables called container, user repo, and data utils. And then we call before. Now in test, you guys aren't aware, there's a concept of before, which in this case means before any of the tests are run, do this. And then there's before each. Before each is before each individual test, do this. We're using before here because we don't want to spin up the test container before each test. We want to spin up the test container before we do any test and then keep it there the entire time. The first line you'll see with number 3, we're actually creating the container there. That one line of code, well, it's 3 lines of code, but I split it out so it looked better on the slide. That one line of code is actually what spins up your Docker container and exposes it to your local host. One line of code, you can create a Docker container that has a MySQL database ready for you to use. I think that's pretty awesome. Then we have our user repo where we create an instance of our user repo. We pass in the username, password, host, the map port, and get database. Those are all coming from the container. So when you spin up a test container with MySQL, you will have this information available to you. You don't have to supply a username. You don't have to supply a password. It's provided for you because it does it automatically. And then we have the ddl.create user table. Again, that's just a file. It's a simple SQL statement that creates a user table with a couple columns in it. And then data utils. Remember, data utils is what we're going to use to test to make sure the data got inserted correctly. And we pass in the same values that we did before, and you'll understand why. Now, normally, you wouldn't have to do the mapped ports. You see up top, it says with exposed ports, and then we have get map port. The reason why I did that is because I'm actually using in the application the XHead API, which needs port 33060 exposed. If you're not using that, you don't have to do anything extra like that. You can just do, you can leave out the exposed ports and it'll automatically know what port number you need to do because it would only be 3306. And then in our after function, just like before, after is run after all the tests are done. After each would be done after each test is run. Again, all we do here is we shut down the container. This is an important step because if you don't do this, you'll have multiple containers spinning up. And if that happens, your system's going to crap out pretty quickly. So you got to make sure you stop the container. And we do that in the after, which is after everything's done, we kill the container. The first test we're going to do, and here you can see it's outlined with, we use the test method. We pass in a little note that says the container should be running. All we're doing here is we're checking to make sure that the container actually started the way we expected. And one of the cool things is the fact that you can actually run container.execute query and you can run queries against that. Here all we're doing is we're doing select one as res, and then we do assert.ok that the results from query result includes the text res line break 1 line break. So if this test fails, that means the container didn't start. And the cool thing is because this is the first test, It's not going to try any others because once you get a failure like this, it stops. The second test we're doing is we're going to create a user. So here the first thing we do is we use Faker to create a username. I console.log the username, which will actually show up in the results when we run the tests. We call user repo.createUser, pass in a JSON object that has the name property where the value is the name that we have. And then query result, you see here we do dataUtils.getUser by name. So the line annotated by 14 is the one that inserts the data. Line 15, or number 15, is going to be we're extracting the data back out again to make sure that we can use to test. And then we have assert equal, that the query result is only one row. Yes, sir.
So I'm wondering, what is the system on the test here? The system on the test is that user repo?
Yes.
So you're duplicating the internal behavior of user repo in dataUtils to make sure that you can extract the data?
We're not duplicating it because in this particular test, we're inserting the data in user repo, but in dataUtils, we're retrieving it.
But dataUtils will need to know the internal representation of user repo to make sense of the data, right?
No. Not really. You'll see. I'm going to go over that in a second. So we have an assert that the query result is equal to 1. In this particular case, I know it needs to be 1 because we just inserted a name and the database should be empty. So your assertion in terms of how much information you got back like that might need to change. And then we just assert that the name value is equal to the first element in the query result and the name property. So this is our user repo, and we have two private variables called connection URL and pool. In the constructor, we pass in the user, the password, the host, the port, and the schema name. We then use those values to create the connection URL, and then we create a connection pool using MySQL x.getClient. We pass in the connection string, and we pass in the pooling information that enables the pool, sets the pool size to 10, the max idle time to 20 seconds, and the queue timeout to 5 seconds. I like using this in examples. You don't need to use a thread pool, but I actually think it's good to demonstrate it because a lot of times people are going to need a thread pool, and then they actually have the example very early on to see. And then we have a function in here called getSession. So all this does is it pulls a session out of the thread pool and returns it. In our create user, again, remember we're using the xdev API in the user repo. So we're actually not writing any SQL in here. So first thing we need to do is we need to get the session, and then we need to get the schema, and then we need to get the table name. Yes, that could have been a one-liner, but it's harder to read. So I split it out into 3 different lines. And then we do table.insert. We pass in an array of the columns we're inserting, which here is we're just inserting name. And then the values is user.name, and we call that execute. And then important, session.close. If you're using a thread pool, you want to make sure you close the session, because if you don't, you will run out of threads. And then your application will crash and your test will fail. dataUtils.js, the top is the same. So we're passing in the same variables, we're creating the same private variables, we have the same constructor. So we have 2 different database connections now. But the difference is, we did the same thing with the get session. But now, remember, this is what we run after the data's been inserted. This is what we're going to use to pull the information back out to make sure the data matches. Here, we're doing just we're getting the session, and then we do session.SQL, and you'll see here now we're doing a SQL statement. Now, the reason why I do this in 2 different processes is because if you're testing the user creation under user repo, and then you use the user retrieval process under user repo, using the same connection, you could get false positives or false negatives. Because if there's a problem somewhere in that case, you're not going to catch it. So I like taking stuff and using a completely different system, a completely different way to retrieve the data. Like if you're using, for example, if you're testing your user service, you don't want to use user service.getUser to test user service.putUser. There should be an external source to do that. And then in this example, I have this function to format data because the information that comes back from that particular query I just ran is kind of formatted a little wonky. And I like it better this way, where it returns just an array of JSON objects, where the syntax is a little bit different the other way. And then to run the test, you do node -- test. You'll see the first thing that pops up is the test name is Rodrigo Bernhard 61. That was the username that was created. And you'll see at the bottom it says it ran 2 tests. There was 1 suite, and the 2 tests passed. If there's any failures, if there's any other problems, they would show up there. And the one thing people like to point out is the fact that here it took 11 seconds to run this simple test. The reason why is this is what happened when I ran Testcontainers for the first time. And when you run Testcontainers for the first time, it has to pull down the image and spin up the document. So there's a little bit of the first time you run your test, there's going to be it's going to take a little bit longer than subsequent runs. So now let's talk about some best practices, because like I said, writing tests is hard, and hopefully this will make it a little bit easier. First thing, avoid hard-coded values in your tests. Over my career as a developer, I've worked with quite a few interns. One year we had an intern come in who seemed like he was pretty bright. So we said, you know what, we're going to give him some basic code to write. So we wrote some tests for him, and he had to write the code to make sure the test passed. Now, what I'm about to show you is not what he did. It's a drastic simplification of what he did, but it was kind of the same thing. So let's say we have a test where we want to test to make sure that myObject.addNumbers, when we pass in the values 4 and 6, that the value returned is 10. Okay? Anybody want to take a guess what his test looked like? Return 10. So here's the problem in the fact that the way this is written, the test pass. But the code is wrong. Why? Because it's a poorly written test. It's a poorly defined test because we used hard-coded values. What I would do is I would use Faker to pull in 2 random numbers, or to get 2 random numbers and then pass those in and then recheck it that way. So you want to avoid hard-coded values. It can cause a lot of problems. When you're writing your test, you should have a test for every logical condition. So every if statement you have in your code, you should have at least 2 tests. One for when the if statement is true, one for when the if statement is false. If you have a case statement, you should have a test for every switch. You have a switch statement, you should have a test for every case. And you should also have a test for a default value, whether or not you have a default value in your switch defined or not. So you need to make sure that every case is covered, as well as when that particular case is not covered. Each unit test should only test one possible scenario. So if you have an if statement inside your code, just one if statement, you should have 2 tests. One for when the if is true, one for when the if is false. You should not run them both under the same unit test. They should be broken out separately. Unit tests, as I said, they should be simple. If you're starting to write complex unit tests, your code might need to be broken out to be tested a little bit easier. And I would much rather have easily testable code than huge monolith function that does one thing and we have to try and test all those things with each test. It's hard to do. Avoid hard-coded values. There's a theme here. This gets people in trouble more often than not with running tests than you believe. Another thing I see people do is they will run unit tests where the result of one unit test depends on the result of another unit test. That's not a unit test. That's an integration test. Kind of. And you shouldn't do that. And mostly because a lot of modern frameworks, they run the tests asynchronously. So you never know when one particular test is going to be run related to another one. So you should always make sure that what you're testing is just in that function or method itself. And if you ever need to make external calls, so you make an external call to an API or even an external call to a different function in the same, or a different method in the same object, you need to stub that out and you need to use mock data. And then all you need to do there is, so if you have user service create user and then you need to validate it, when you're testing create user, all you're doing is you're testing to make sure that the validate function was called, because the validate function is going to be tested on its own. All of your tests should be automated. It should be part of your CI and CD process. And this is for unit tests and integration tests. Project I worked on, we had, I think there was 8 developers, and the guy who was in charge of setting up our CI and CD process had a sense of humor. And anytime you checked in code, it would run the test automatically. And if the test failed, everybody on the team got an email that said, the subject of the email was, Scott broke the build, or developer name broke the build. And you never wanted to get those emails because you knew everybody just found out that you screwed up. You did something wrong. And it really did help us be more accountable to our code. And then lastly, avoid hard-coded values. If you walk away from this talk with any new thought in your head, it should be to avoid hard-coded values in your test. They will cause you problems down the road. I guarantee it. If anybody has any questions about this presentation, you can reach me. My email is scott.stroz@oracle.com. I'm on Blue Sky at stroz.dev, Mastodon at Stroz, and LinkedIn at Scott-Stroz. Any questions? Yes.
So how do you reproduce a test with random data? You have a seed that you can just send?
Yep. Yeah, so to use random data, a lot of times I would use something like Faker to create the random data, and then you keep those values set so that when you're going to read the data again, you can compare it.
Okay, so sometimes when I do random testing, I actually use the proper random function and the seed for that.
Mm-hmm.
So then I can just set the seed, and then I can pull the same random data again.
You could do that too.
Okay.
Yeah, so what you're talking about is I kind of used to do that until I found Faker. You know, when I was actually giving this talk, that somebody was like, have you heard of this? And I'm like, no, but I love it now. So I changed the presentation. So I used to write also, I had like a get random number, get random string. Those are things that I used to use myself, that I used to write myself.
Faker doesn't have something like a seed to start with. You actually copy the thing.
It might. There's so much in Faker, I only begin to scratch the surface on it. Yes, sir.
Thank you for a great presentation. Do you have any kind of functional integration performance test we as the operator developers should execute?
So just to make sure, is there any test for
Database operator developers, we are not interested in unit tests that should work already, but your performance.
So you're talking about like as a DBA or something like that? Is there any test you can run? There probably is, but I'm not aware of it. I'm not a DBA, I'm a developer. So that's why I talked about this stuff. So.
Thanks.
Yes, sir.
The Testcontainers library is available in other languages other than Go?
So you're asking if Testcontainers available in other languages? Yes, Testcontainers are available for Java, I believe Python, possibly PHP, and they're also available for other database systems. So there's an Oracle DB test container. So they're not just, this is MySQL. Test containers can be used for a lot of things. They also promote that you can use them for UI testing as well.